This is lesson 10.4, part 1 of 3 videos. The Pythagorean theorem deals with sides of a right triangle and their relationships. And to use them, you have to understand the hypotenuse, which is the side opposite the right angle. In other words, it's always the longest side. The legs are the two sides that form the right angle. So in this picture, these are the legs because they form the right angle, whereas the hypotenuse is the side opposite the right angle and also the longest. Pythagorean triple is three whole numbers that satisfy the Pythagorean theorem. The first example of that is 3, 4, and 5. So the two legs being 3 and 4, if you use this relationship, it'll equal 5 for the third side. So all are integers, thus making it a Pythagorean triple. The converse we'll talk about later when you switch an if-then statement around. So first example, if we utilize this relationship that's given up above, right here, the two legs are considered the 12 and the x. So 12 squared plus x squared equals 15 squared, which gives us 144 plus x squared equals 225. Subtract 144 from both sides and you get 81, in which we would solve by rooting. And if you remember, when you solve by rooting, you'll get a plus minus. But because this is an applied question and we're talking about distance, it's only the positive value. Next question. The two legs are the two sides that make up the right angle. So 7.3 squared plus 15.2 squared equals x squared. So we have 53.29 plus 231.04 equals x squared. You put those together and x squared equals 284.33. You root both sides and we get x equal to 16.9. Now I could have just rounded those to the nearest tenth, which is what's mentioned here, but I did that with the answer. But I could have done that right here and right here also. Alright, another question, but we have different kinds of numbers here. Find each missing length, leave your answer in simplest radical form, which means no decimals. So we're back to our reducing. So we follow our pattern again and notice that these are the two legs. They make the right angle. So we would say root 37 squared plus x squared equals 15 squared. The square and the square root cancel each other out, which gives us 37. 15 squared is 225. Subtract 37 from both sides and we get 188. Square root, and x equals root of 188, which is not simplified. We can't take the root of it and get a decimal because the direction specified to simplify and keep it in a radical form. So we go back to our old methods that we discussed earlier and break it down. So 2 and 94, 2 and 47, and 47 is prime. There's your two terms. So you would say x equals the square root of 2 squared times 47, which gives us, puts it out front, which gives us 2 root 47. Our last example will be example 4. In example 4, we notice again the two legs. Our two legs are here and here, which gives us 8 squared plus 10 squared equals the hypotenuse squared, which is 64 plus 100 equals x squared. X squared is equal to 164, in which we would root to solve, which gives us x equals root of 164, which we would then factor down to 2 and 82 and 2 and 41, and here's our 2's, so that would equal the root of 2 squared times 41. That comes out, and you get 2 root 41. This ends part 1 of 10-4 video.